All right, this is the first free response from review day 7, and we're given a differential equation. We're told at time 0 there were 10 grams of a substance present, and the first thing says use the tangent line at t equals 0 to approximate the amount of the substance at 2 seconds. So what we want to do here, again, if we see tangent line, we always think point and slope to start with. So our point at t equals 0, there's going to be 10 grams. So it'll be 0, 10. As far as the slope goes, we have to use the derivative. So the derivative is negative 0.02 times y squared. Y is 10. So our derivative, our slope, will be negative 0.02 times 10 squared, which equals a negative 2. So that's our slope. So y minus 10 equals negative 2 times x minus 0, or just times x, which really is t in our problem. So I'll just use t there. And really, if I add that over, I get y equal to negative 2t plus 10. All right, so that's my equation of my tangent line. So if we're using it to approximate what's going on at 2 seconds, y at 2 seconds will be negative 2 times 2 plus 10, which gives us 6 grams. Okay, so you got 1 point for finding the slope at this spot, and then 1 point for making the approximation there. Okay, so not too bad, as long as we understood that that was our derivative, right? Now B says, using the differential equation, can you say whether this would be a graph for the original? Now, a couple different ways you can do this. This talks about how things are decreasing, and how we have something decreasing for a little bit and then increasing. If you look at your function dy dt, okay, it doesn't matter what y is, we're squaring it, so this part will always be positive, so you're going to have a negative times a positive, so dy dt is always less than 0. Therefore, y is always decreasing, and this graph is not always decreasing. This graph has a little bit of a part that's increasing. So this cannot be the graph due to a part that is increasing, or something along that nature, right? This graph has both a decreasing and an increasing part, but if it was for this graph, it would only have to be decreasing. They gave just 1 point for this. As long as you had something that was reasonable in this area, then they gave it to you. Okay. C says find an expression for this, solving this with the initial condition. So this is this separation of variables. What they wanted you to do is pull the y squared over. We'll do this down here. So you'd have dy over y squared equals negative 0.02 dt. All right, if you separated your variables, you got a point. Then you're going to integrate. So dy over y squared, well, we'll just write that as y negative 2 equals the integral of negative 0.02 dt. Okay, this is going to go y negative 1 over negative 1 equals negative 0.02 t plus c. Okay, if you had that integration, you got a point as well. Now we want to find out what c equals, so we're going to put in 0 for t and we're going to put in 10 for y. So what we are going to get then is a negative y to the negative 1, so that's 1 over y, so 1 over 10. So I did two things there. This negative kind of came out. We flipped this down to 1 over y, and then we put the 10 in for it. 0 goes in for t, and so that's c value right there. So we end up with c equal to a negative 1/10. That gave you another point. And now we got to figure out what y is. So going back to my original, I'm going to have negative 1 over y equal to negative 0.02t minus 1/10. Now what I can do then is just multiply everything by negative 1. So I get 0.02t plus 1/10. All right? And then at this point, I'm going to just go ahead and flip everything. So we're going to get 1 over 0.02t plus 1/10, or 0.1. You're welcome to leave it. That would give you your point. But if you didn't want that, if you wanted to be a little fancier, it does simplify into this. We won't worry about that right now, but this would get you the point here. All right. Then the last question says, determine whether the amount of substance is changing at an increasing or decreasing rate. In other words, is the derivative increasing or decreasing? In order to answer that, we'd have to find the second derivative. So what we want to do here is take the second derivative, all right, which if we take the derivative of our original, will just be negative 0.04y times dy dt, which will give us negative 0.04y times negative 0.02y squared, which gives us a positive 0.008y cubed. Okay, now they gave you a point for having that derivative, all right? And then because y is greater than 0, we know that we're using positive y values here. Since that's happening, we know that this is going to be a positive times a positive. Therefore, our second derivative is always positive as well. And because the second derivative is positive, we'll just say dy dt is increasing. And that would give you another point. So there's your 9 points.